Welcome to this presentation on electromagnetic levitation. Magnetic levitation as a concept is easy to grasp. The force generated by two magnets can be used to lift one of the magnets above the other, but it's hard to keep stable due to other disturbance forces such as gravity or air pressure. In the mid-1800s, Samuel Earnshaw proved that it was impossible to achieve any stable system out of electrostatic or magnetostatic fields. From Maxwell's equations, we know the divergence of a magnetic field in static conditions is zero. However, a stable system is one that tends to maintain its equilibrium. For a magnetic levitation system, this would imply negative divergence pointed at the position with the lowest potential, but if there is no divergence, this can't be the case. However, there are some ways around Earnshaw's theorem. Using electromagnets, we can manipulate the magnetic field affecting an object within the field. We see this in some applications like floating desk objects or novelty toys, but this is also the basis of the technology involved in the new forms of high-speed travel that are popping up around the world, maglev train systems. Maglev trains differ from normal trains in that they are not physically touching any rails. Instead, maglev trains float above a guideway and are propelled by time-varying magnetic fields generated by electromagnetic coils in the walls of the guideway and the trains. These fields are generated by AC current running through the coils, leading to alternating polarities that move down the length of the track. Magnets in the train respond to these fields and propel the train. There are two main systems in use around the world. In electromagnetic suspension systems, the bottom side of the train wraps around the underway. Magnets on this section are attracted upward to the underside of the guideway, causing the train to lift above the track. This system was developed in Germany and can reach speeds of about 300 miles per hour. While EMS relies on attractive forces for levitation, electrodynamic suspension, developed by Japanese engineers, relies on repulsive forces. In EDS, supercooled conductors are placed in the sides of the train and magnetic coils, shaped like figure eights, line the guideway walls. The two halves of the coils have opposing polarities, which both interact with the superconductors to have a balancing combination of attracting and repelling forces that keeps the train balanced and floating between them. Maglev has some advantages and disadvantages. Little to no friction means parts do not wear easily and need to be replaced and repaired far less often. They generate almost no air pollution because the system runs on electricity and requires no fuel to be burned. The major downsides to maglev are that they can't be built on top of existing train infrastructure. It must all be developed from scratch, and they require some rare metals to be used for the magnets. Hyperloop is a concept that was first introduced by Elon Musk in 2013. In the Hyperloop, pods would travel through steel tubes in near vacuum conditions and rely on the same concepts of magnetic levitation and propulsion. There are some drawbacks to the Hyperloop system. The cost of construction is very expensive, with 1 kilometer of track being priced at around $75 million. The speed of travel creates a strong centrifugal force that has been known to induce nausea. And of course, using enclosed pods in an enclosed tube system means there's no escape from broken down pods or pods that may collide with one another. However, there are also positive aspects. The system could end up linking many cities and revolutionize the travel needs of customers, contributing to lower carbon emissions and reducing traffic congestion. While Musk originally proposed the concept, more companies are working on their own prototypes. In 2016, Hyperloop One, formerly Virgin Hyperloop, began building a 1,600-foot long track in Las Vegas, and in 2020, 2 employees became the first 2 people to test a completed Hyperloop system. More test tracks have since been built in France and Germany. However, due to the high cost and imperfections of the system, many projects have been scrapped. But that doesn't mean we're done with Hyperloop just yet.